Hi, my name is Christian McCollum. I'm one of 4 team members on the VLF team here at ASU for electrical engineering. Other team members include Makea Di Silvestro, James Jacobs, and William Howard. I was invited to this particular project through the use of discussion boards online. As for the goal for our project, we're basically trying to design a low power electronic device to be attached to a UAV unit and then hopefully detect low frequency signals such as power lines or lightning strikes while in flight. Our mentor that has been assigned to this project is Professor David Ali at ASU. He'll help guide us and help us with any questions or concerns that we have for this project. Makea and William will be considered on campus. As for myself and James, we are off campus. James and I will help Makea and William by mailing in our portion of the project for them to utilize in the lab section, and hopefully it'll get all working and hopefully detect the low frequency signals as we go further in the project. So far we are deciding to whether or not to utilize the ferrite or loop antenna rod to detect the low frequency signals, and we're still purchasing most of the products to utilize in this project. I will pass it along to my other team members, James, Makea, and William. That's all for now. Thanks.
Hi, my name is Makea Di Silvestro. I am on the UAV team. The UAV team is split into 2 teams, the EO team and the VLF team. I was asked by another student that I've met through courses online if I wanted to be on the VLF team. The mentor for both teams is Dr. Ali, and the goal for the VLF team is to create an antenna small enough to go onto an airplane that will pick up low frequencies, which is anywhere from 30 hertz to 100 kilohertz, that will pick up electromagnetic waves such as lightning strikes and power lines and any atmospheric noise.
Hello, my name is James, and I'm on the ASU remote sensing team, more specifically the VLF, very low frequency team, in which we are going to design an antenna that's going to be placed on top of a drone that's going to be flown around so we can intercept radio frequency emitted from power lines and weather phenomena, lightning strikes specifically. And we're going to intercept this from flight, and we're going to have the processor on the drone as well. And once it gets back to the ground, we're going to be able to interpret that data and look at it more closely. We've talked about the workflow, the distribution of labor, where different options that we would have. One option that we had is we would design 2 different types of antennas, try them both out, see what works better, and decide to put that in our final project. We haven't exactly figured out everything that we're going to build yet, because we're still in the design phase right now. But once we get that going, we're going to have a lot more documentation, and we're going to have a lot to show for it. So I'm looking forward to working with everybody, and to be a great 2 semesters. Thanks.
Hello, my name is William Howell. I'm a part of the VLF Detection Group, which is a subdivision of the UAV remote sensing project under the mentorship of Dr. Ali. The intent of this project is to develop hardware that can be carried by a UAV to detect low frequency sources such as power lines, the WWVB radio station in Colorado, and possibly lightning strikes. This hardware consists of an antenna, an analog to digital converter, and a storage device. The difficulty in this project is to design a small, lightweight antenna that is able to detect very low frequencies and a means of storing this information with intent to maximize data and limit power consumption. This payload is of course intended to operate while the UAV is in the air. Then, once the UAV has landed, the data can be retrieved for processing and analyzing. In terms of progress, we have constructed the UAV and are now working on programming the autopilot. Various group members are currently buying the necessary supplies such as a Raspberry Pi to act as storage, an Arduino to act as an analog to digital converter, and finally copper wire and ferrite material to build the VLF antenna.